For metrology and measurement subject, the multiple choice questions on Unit IV form measurement is presented in this video. First question, the bench micrometer measures option A, the major diameter of the thread, B, the minor diameter of the thread, C, the effective diameter of the thread, D, the root diameter of the thread. Answer is A. Bench micrometer measures the major diameter of the external thread. So bench micrometers are used to find the major diameter. So the arrangement of bench micrometer is shown in this figure. So for taking measurement, first we have to compare. First we are in need of a standard cylinder. Okay, the standard cylinder dimension is known. Then the micrometer anvil, bench micrometer anvil is hold in this standard cylinder and the readings are taken, and this reading is taken as R1. Then that the micrometer anvil is bench micrometer is moved to the workpiece whose major diameter is to be measured. So here the reading is taken. Okay, the major diameter of the thread is taken and this reading is R2. So and it has been calculated using the formula. Major diameter is calculated using the formula D plus S. S is the size of setting gauge. Okay, we have the settings standard cylinder and this is called a setting gauge and this dimension is S, and R1 is the micrometer reading over the setting gauge. Okay, over the standard cylinder, R1 is a micrometer reading over the standard cylinder, and R2 micrometer reading over the thread. Okay, R1 the micrometer reading over the standard cylinder and R2 micrometer reading over the thread. So the major diameter is, so instead of calculating directly micrometer reading over the thread, and a standard cylinder is used, standard cylinder plus micrometer reading over the standard cylinder minus micrometer reading over the thread. Okay, this is plus or minus. So ordinary bench micrometer is suitable for measuring external major diameter for external threads. It is first adjusted for appropriate cylindrical size having same diameter. This process is known as gauge setting. After taking reading R1, micrometer is set on the major diameter of the thread and the new reading is R2, and the major diameter is calculated using the formula D equal to S plus or minus R1 minus R2. So the bench micrometer measures the major diameter of the thread. It does not measure minor diameter. To measure the effective diameter of the thread, 2-wire method, 3-wire method, thread micrometers are used. And the root diameter of the thread is not measured using bench micrometer. Bench micrometer just measures the major diameter or outer diameter of the thread. Next question, the floating carriage micrometer measures the minor diameter of the thread. So bench micrometer measures the major diameter of the thread. The floating carriage micrometer measures the minor diameter of the thread. So this is called as the measurement of minor diameter by floating carriage micrometer. Minor diameter is measured by a comparative method by using floating carriage micrometer measuring machine and small V pieces which make contact with the root of the thread. These V pieces are made in several sizes having suitable radii at the edges. V pieces are made of hardened steel to avoid wear. So floating carriage micrometer measuring machine is a bench micrometer mounted on a carriage. Okay, it is a bench micrometer, but it is mounted on the carriage. So to measure the minor diameter, V pieces are used. 2 V pieces are used in floating carriage micrometer. So there is a standard cylinder similar to the previous case. So this standard cylinder, there is a V piece. The 2 V pieces measure the 2 V pieces. First standard cylinder dimension is S or D. Then first reading is taken at the standard cylinder and this reading is R1, and the second reading is taken as R2, and it measures the diameter at the root. It is not at the crest, it measures the diameter at the root. So it is a minor diameter and this reading is R2. Okay, and this can be calculated using the minor diameter of the thread can be calculated using the formula D plus or minus R2 minus R1. D diameter of cylindrical gauge, R2 a micrometer reading on threaded workpiece, R1 micrometer reading on cylindrical gauge. Okay. So in floating carriage micrometer, V pieces are used to find the minor diameter, and it measures a diameter at the root, not at the crust. Crust is a projected portion, upper portion, and root is a bottom portion. It measures a minor diameter of the thread. Okay, the procedure is similar to that of the previous bench micrometer, but it measures a minor diameter. So the floating carriage micrometer measures the minor diameter of the thread. Answer is B. Next question. Taper parallel method and rollers method are conveniently used to measure the minor diameter of the internal thread. Okay, they are used for measuring the minor diameter of internal threads. So the bench micrometer and floating carriage micrometers are they measures the external and internal diameters of the external thread, but it measures the internal thread. So minor diameter of the internal thread. So minor diameter of internal threads are measured by taper parallels and using rollers. Okay, this is a taper parallel. Two such taper parallels are used to find the minor diameter of internal threads. For diameters less than 200 mm, the use of taper parallels and micrometer is very common. The taper parallels are pairs of edges having reduced and parallel outer edges. So two taper parallels are used. Okay, the diameter across their outer edges can be changed by sliding them over each other. Okay, so we have to fit a taper parallel, and finally using a micrometer we can measure the diameter at the outer edge. It is an indirect method of measuring minor diameter of internal thread. Okay, the diameter at the root is called as major diameter. Diameter at the crust is called as minor diameter. For external threads it is different. Here it is a diameter at the crust is called as a minor diameter for internal threads. So it measures minor diameter of internal threads. Okay, by inserting two taper parallels. After inserting two taper parallels tightly, we can measure the diameter by using a micrometer anvil. Then another method is roller methods. Okay, so not only rollers are used, along with slip gauges are also used. So two such rollers are used. The total minor diameter is equal to the diameter of the two rollers plus the thickness of the slip gauges. For more than 200 mm diameter, this method is used. For less than 200 mm diameter, taper parallels are used. For more than 200 mm diameter, these rollers are used. Precision rollers are inserted inside the thread, and proper slip gauge is inserted between the rollers. The minor diameter is in the length of slip gauges plus twice the diameter of the roller. Okay, minor diameter of the internal thread is equal to the diameter 2d plus thickness of or length of slip gauges. Next, major measurement of major diameter of an internal thread. It is very difficult to measure the internal diameter of the major diameter of the internal thread because we have to measure at the root of the internal thread. For this, a wax or any other material is inserted into the thread, and a perfect cast have been obtained. Okay, obtaining the cast of the thread. An indirect approach of measuring internal diameter is obtained by obtaining the cast of the thread. The main art thus lies in obtaining a perfect cast. So after obtaining the cast, the diameter is measured using the micrometers, and thus the major diameter of internal thread can be measured. It is an indirect approach. Pitch measurement. For measuring pitch, we are using tool makers. Mainly we are using tool makers microscope and screw pitch gauge. We will discuss tool makers microscope. Tool makers microscope consists of a base, an optical head. The upper part is called as optical head, and the right hand side part is called as a supporting column. And there is a table in which the workpiece whose pitch is to be measured, the thread whose pitch is to be measured is placed over the table. in the tool maker's microscope, and at the bottom there is a lamp, and there is a collimating lens, and the collimator lens makes the beam parallel. Okay, in the mirror it is reflected to 90 degree, and it passes to the work table with the carriage, and we can set the workpiece using micrometer dials. Okay, using micrometer dials you can set the workpiece at the center of the beam, and the image is taken to the optical head. Okay, and the image can be, and the pitch can be measured through the eyepiece, micrometer of the eyepiece. This is the working principle of tool maker's microscope, and this is used to find the pitch of the threads in the tool maker's microscope. And at the bottom and the base, the lamp and collimating lens and mirror are available, and the beam of light is passed through this glass which is provided on the table, and the workpiece is placed over the table, and the image is passed to the optical head, and the image can be, and the pitch can be measured through the eyepiece. Screw pitch gauge, which is also used to measure the pitch of the threads. The thread micrometers measures the effective diameter of the thread. Okay, 2-wire method, 3-wire method, and thread micrometers are used to measure the effective diameter of the thread. Okay, effective diameter measurement is carried out by following methods: 2 wires method, 3 wires method, and micrometer method. 2 wires method, 2 wires are used. Okay, best wire size of the wire is taken, and the 2 wires are placed over the placed in the threaded portion whose effective diameter is to be measured. Okay, so the effective diameter is measured. Effective diameter is a diameter at the pitch. Okay, diameter at the pitch line. So effective diameter cannot be measured directly, but can be calculated from the measurement made. Wires of exactly known diameters are chosen such that they contact the flanks at their straight portions. Okay. So for this we need a best wire size. Best wire size should be taken. A screw thread is mounted between the center wires and are placed in the grooves, and the reading M is taken. And the reading M is, first we have to take the reading M. Okay, by placing the wires we have to take the reading M. Then the effective diameter is equal to M minus 2D plus P. Okay, T equal to M minus 2D. 2D is nothing but the diameter of the wire. Small d is the diameter of the wire. 2D, M minus 2D plus P. So P is a value which depends on diameter of the wire. P is a value which depends on the diameter of the wire. So M minus 2D, effective diameter is measured using M minus 2D. M minus 2D. 2D is nothing but the diameter of the wire. Okay, M minus 2D plus P. This P value depends on the P value is a value which depends on diameter of wire, pitch, and angle of screw thread. So this is called as 2-wire method. And 3-wire method. 3-wire method, the same principle is used. Okay, instead of it will have a good contact. 3-wire method, the same procedure, the same formula, method of finding the effective diameter is same as that of the 2-wire method. Best wire size is can be calculated. So thread micrometer measures. Thread micrometer also measures the effective diameter of the thread. 2-wire and 3-wire methods also measures the effective diameter of the thread. Answer is C. Then the best wire size for isometric thread in terms of pitch is 0.5773 P. So in pitch, P is pitch, 0.5773 pitch. A metric thread of pitch 2 mm and thread angle 60 degree is inspected for its pitch diameter using 3-wire method. Diameter of the best wire size in mm is 0.57 into P. So pitch is 2 mm. So 0.57 into 2 mm equal to 1.154. The answer is C. Okay, 0.57 into 2 mm. So it is greater than 1. Okay, but less than 2. So it is 1.154 mm. Answer is C. Which one of the following is not true about pitch error in screw thread? So pitch error. So if pitch error is present, so it is not true. It increases the effective diameter of bolt. It occurs due to incorrect tool work velocity ratio. If there is some error in pitch, then the total length of the tool engaged will be either too small or too great. So answer is B, it increases the effective